Okay, welcome to Mtare TV. And in today's video we're going to look at pure chemistry, ECZ pure chemistry, a question which came in 2018, which should be question 7. The topic is on electrolysis. That's the topic we're going to look at, or the question we're going to look at is electrolysis, pure chemistry. So I'm about to solve this question, but as I'm solving, I hope you'll learn one or two things. I'll try to explain while answering questions as well. Okay, so the question reads: molten sodium bromide was electrolyzed using the experimental arrangement below. Okay, so we have this arrangement of molten bromide. So there we have electrode B, and we have electrode A, and we have molten sodium bromide. Okay, so moving on to question 1. So question 1 here we have question 1 saying what ions are present in molten bromide solid, or in molten sodium bromide. Okay, so the ions which are present in molten bromide are say solution, okay, and we have we have number 1A, and we have been asked to name the ions present. So the ions present in molten sodium bromide are sodium. Don't forget, we are dealing with ions, so you need to add a positive there just to show that this is an ion we are dealing with. I'm just a bit okay. Hope you can see now. So you need to add a positive sign on top here to show that we are dealing with an ion. Then another ion which is present is bromine ion, which is like a negative on top to show that these are ions. So these are the ions which are present in molten sodium bromide. Okay, so when a substance is said to be molten, it simply means it has been heated in such a way that it has reached a point whereby it has melted. Okay, no water was involved. Hence, the only two ions present in that solution would be sodium ions and bromine ions. Okay, so move on to question B. Question B reads: state what you would see at electrode A. So at this electrode, what can you see? So before you answer this, you need to understand that when you have two electrodes, right, and you have a cell there on top, which is like this. Okay, you have two electrodes like this, right? And in our diagram, on the positive side you have electrode B, and on the negative side you have electrode A. So how have I identified this is a negative part and this is a positive part? Simple. If you look at here, the cell should be a label here to indicate that this is this is a cell, right? So if you look at the cell right here, you'll see at the one where it's starting, where it has a small line here, this one here, a small line here, simply means it's a negative. While the one where on the other side where it is starting with a big line, that's why you identify this as a positive. And they know that under electrolysis, the positive part, or the electrode which is connected to the positive terminal, is known as anode. Okay, anode. Then the one which is connected, the electrode which is connected to the negative part, is called the cathode. Hope we are clear there. So now I've been asked what reaction. Where's question B? State what you would see at electrode A. So electrode A, we have identified it's it's a cathode. It's a cathode, and we know that in electrolysis, so we're going to have what ion is present in this electrolyte. So the electrolyte is simply the solution, okay, and in other words the liquid. That's what we call it, electrolyte. So the electrolyte of molten sodium bromide is what? It's going to contain sodium what? Sodium ions and the ions. Okay, so now there is a way in which these ions move in the electrolyte when you apply power or you apply current in this electrolyte. So what will happen is that the ion with a positive charge to be attracted to the negative part, which is what? The cathode. So this will move to this electrolyte, right? Why? Because this is a negative part and this is positive. Different signs, they do what? They attract. So here you will see that here is what is negative. There's a charge of negative, so which means it will go to what? The anode. Okay. So like I've said, the positive ions will be attracted to what? To the cathode, which is the negative part or the negative terminal of the battery, and the negative ions will be attracted to it, the positive part, which is what? The anode. I hope we are clear. And if you look at the question given here, our anode has been labeled as what? Electrode A. And we know for a fact that the ions which are present in molten sodium bromide are what? Sodium ions and the bromide ions. So one which going to be attracted to the cathode is one which is what? Positive. So in this case, the one which is positive is what? Sodium. So hence sodium will be attracted at electrode A. Okay, well done. You have identified what ion will be attracted to electrode A. So now let's go back to the question. State what you would see at electrode A. So what you see is that a color change from a color change, which is B, a color change from orange to what? To green. Why? Because the sodium will be formed, the mass of sodium will be formed at this cathode here. So what you will see is what the color change from orange to green. Maybe. So we go to question what? Question C. Write. We have been asked to do what? Write the ionic equation with state symbols for the reaction which occurs at electrode A. Okay, so electrode A, we know that what will be attracted is what? Sodium. So we're going to write sodium. Remember, we said this in what? In molten state. Simply means that it has been heated, whereby it melted. So means no water was applied. So this won't be in aqueous form, but rather in what? In liquid form, and the positive what? Charge there. So you need to be careful in chemistry. These things may seem silly, but they are important. They are the fundamentals of what? Chemistry. So okay. So as I was saying, these are the fundamentals of chemistry. So here what will happen is that at the anode there, this sodium ion will receive or will lose one electron. Okay. So when this loses one electron is going to be in what? In a solid form. It's going to become what? An atom, but in what? In solid form. When this loses one electron, it's going to become what? An atom. That's why this positive charge has disappeared on top there. Hope we are clear there. So moving on to the next question here. C, we have answered. You're going to D. Write the overall equation for the electrolysis of molten sodium bromide. Okay,